Good evening, all. We are super excited to have you all here. Today we have Ravin Pereira, who is a backend developer at Rely, and he's going to talk about why Go a journey through Golang benefits. Ravin, screen is yours.
Hi, thanks, Jamod. I would like to welcome everyone to this session on why we should use Go language to your next project, and then um, a simple journey through all the benefits that we could get using Go, and we would walk through the features that we have with Go. So I would like to share the screen right now, Jamod. Cool, thank you. Um, so in this, I would not go and touch about, I would not teach you Golang, and it would be just a stepping stone for you guys to see if Go suits best for your next project. Um, if you haven't used Go before, or if you have just touched Go a little bit and you didn't know that Go can do all these things, so this would be a good opportunity for you guys to learn more about why use Go. So a bit about me. I'm Ravin. I'm currently working as a backend software engineer at Relay in Switzerland. Um, we are a Bitcoin company, and we leverage the the performance and the great benefits that Go brings us to our microservices. And before that, I was a specialist software engineer in LZEG for 4.5 years, and I've been using Go since 2016. So I have a fairly bit of experience on the evolution of Go from its stable one version one. So before we touch anything else, just a bit about the history of Golang. It was designed by these three people: Robert Griesmer, Rob Pike, and Ken Thompson. Um, they designed this while they were working at Google, so all three are Google employees, and their main objective was to design a really simple but a fast performing language uh, that can help write Google's internal tools. And they developed this in 2007, and then they released it to the public in 2009, so that everyone can use. And Go's version 1 was released, I think, on in 2012, and now it's been evolving a lot, and now we have Go 1.20 as the latest stable version. Okay, so let's dive into the features and the benefits of using Go. Right, so all of the things that I'll be talking about here are some of the main things that I really like about Go, and why I choose um, Go for writing the microservices that I write. So the simplicity in syntax of Go is something that I really like. It has no complicated stuff in the syntax. It's a simple C-like syntax. There are no unnecessary code. Uh, so for an example, you have a for loop in Go, but there is no while loop, because the for loop without any expression acts as the while loop for Go. And you don't have any semicolons or colons for new lines. You just have the brackets, and there is no like the Go formatter handles that for you. And you have the switch statement that you can use for chaining if and else statements, which is quite neat. uh, for a clean code. And also the public and private variables, constants, functions uh, would be defined like when you say, um, when you write your code, you define your variables with an upper camel case, then it's a public variable. So the first letter of your variable, if it's an uppercase letter, it's a public variable, and if it's a lowercase letter, it's a private variable. So public and private variables, um, if you're coming from a Java background, these public and private variables does not mean that they belong to a class, because Go does not have a class. If it's defined inside a package, it's um, it's private to that package. And if it's declared inside a closure like a struct or a function, then it's private inside the function. Um, and if it's public, like if it's an uppercase letter at first, you can um, just use the package name or the struct name and use the that public variable anywhere. So because of the simplicity in the syntax and less complicated code, it's easy for someone to learn Go pretty fast, and so the learning curve is really low. Next, the how the code compiles in Go is that Go compile your code to a binary file. So um, there is no virtual machine. Go is not an interpreted language. It compiles all of your project files into a binary that you can run, and you can build and compile your code in any platform, in macOS, in Linux, in Windows. So Go supports multiple platforms, and it also compiles really, really fast. In a matter of seconds, you can compile a big project. And since there is no virtual machine between the Go code um, that runs, uh, it runs really fast. It talks to the machine directly, and the Go runtime helps you with your memory management and the Go routine, which is its thread scheduler and all the other things. And because of this, Go has, if you write a process in Go, it has a really, really low memory footprint, which you could deploy and which you could deploy easy. And many cloud providers support free hosting, like free deploying for Go processes. So that's because when you write an HTTP server with Go, you can almost deploy it in major cloud providers for free. And just complementing on the simplicity of syntax, Go has less complications compared to other languages. Go has no classes. It has simple structs, and structs can have their methods. And you can write functions anywhere in your packages. They are first-class citizens. That means you can use functions without anything. Like, you don't have to bind functions to a class. You can just use functions anywhere. And there would be no unused variables in Go, because if you define a variable and you don't use it anywhere, the Go code will not compile. It will give you an error. And then Go also supports multiple returns um, in your functions, and it's also statically typed, uh, which means you have to define the type of your variables at compile time, which avoids a lot of confusion in your variables, because you know the type of your variables that you get into your functions. So talking about the simplicity in the code, so To write a simple HTTP server, this is all you need in Go. Um, and if you are a C language user or a C++ user, you would um, mainly a C user, then you would be familiar with how this code is structured because the Go code is quite similar to how we write C. And it's also a bit of like the code is simple like Python. And another thing is Go has a lot of in-house tools, so you don't have to um, get these tools from anywhere else. Go have them like distributed from the Go project itself, and they can be integrated into IDEs to write cleaner code in your project. So I'll go through the example. So the first one is the Go formatter. So whenever you write your Go code, um, the Go FMT tools helps you to format your code um, the way the Go has defined. So if I show you an example of that, so if I just just keep new lines like this, and if I run Go formatter here, the Go formatter will automatically remove those new lines and just format your code uh, very cleanly, so you don't have to worry about that. What you see here is that my IDE is integrated with the Go formatter. Um, so whenever I have multiple lines like this, when I hit Control S, it's just formats the code. So that's how you can integrate the Go tools inside your IDE itself. So another tool is GoWet, which is like a static analysis tool, which will give you errors and warnings about if you're trying to print um, a string as an integer, um, etc. So GoWet would let you know if you have any um cyclic dependencies and things like that. So GoWet is a good tool to run for static analysis, and IDEs have this integrated as well. And Go has its own test tool, Go Test. It's pretty easy to write tests in Go. You just name your Go file with a prefix and then underscore test, and then you start all your test functions with the word test, and then it will be automatically regarded as a test. And then you can also do benchmarks. So you can um, you can analyze the runtime of your code and do benchmarks to see if something is lagging. So benchmarking in Go tests is pretty easy. You just have to run your Go test with a benchmark flag. And then you can also do Go doc for documentations, which means when you write comments as the Go doc uh, documentation has specified, and then when you run the command Go doc, it will generate the documentation for your code. And then one important thing is the Go profiler, which gives you a really great opportunity to look at the memory, the CPU, and how the Go routines, which are the threads, are performing. And it will also visualize those things for you in a graph. And to integrate the Go profiler, you just need to add, a simple header line, and that's it. You can run your Go profilers in your HTTP service. And at last, there is also a Go imports command that you can run, which would um, which would look for imports that are not included in your file, and it will also solve that. So it's another great tool, and IDEs have that included in them as well. Right. So if you're coming from a C++ background and a C background, you would know about pointers. So Go gives you the ability to manage your memory with pointers. Um, so you can pass your types by value or by reference. You have the choice. The asterisk mark, which we use in C++, lets you define your types as a pointer, and then when you use the asterisk in the object you created, you can dereference the pointer. And then you can also use the ampersand operator to get the memory address of a type that you have defined. So if you see in this example, I have a struct called foo, which has one member, which is a bar, a string, and then when I declare this here like this, the foo, I'm creating an object from the foo struct. This is not a pointer. This is just a variable. And then when I use the ampersand to define this, it becomes a pointer. So this is a pointer value which you can pass inside functions, which would reference this foo object's memory address. So when you pass this um, among functions, you can mutate its state, and it also saves memory. So rather than, let's say you have a big structure here, which takes a lot of memory space, and you don't have to you don't want to pass this by value to functions every time, because it would create a copy of this in the memory each time. And when you have a pointer like this, you can pass the pointer to functions, and this memory address will be referenced by everyone, and you won't have to create this in the memory every time. You don't have to copy this. Um, and you can declare variables as pointers like this, and you can also dereference the pointer and get its value by using the asterisk sign at the top. Right. So that's about pointers. Um, so the next great benefit in Go is the concurrency, which um, which takes Go to a whole new level with the other languages that we have. Um, because with other languages, you have complications when you define threads, how these threads would run, what's the context of these threads, um, and also um, in some programming languages like Python, you don't have the inbuilt ability to write threads. Uh, so Go removes all those complications and gives a major abstraction called a Go routine, which is a concurrent process. And we have to adjust our mind to find the difference between concurrency and parallel processes. So when you talk about a concurrent process, concurrent processes, they run um, independent of each other, but it does not guarantee that they would run at the same time. But in parallel processes, you have independent processes, but they also run at the same time, which means they would be processed by two physical processes. So Go removes that complication from users and abstract it with Go routines. So when you write a Go routine, um, Go will look in the thread pool and then get a thread and run the Go routine on top of the thread, which gives you a lot of abilities to write Go routines without thinking, without having the hassle of thinking about how these would be run uh, actually in the processor. So Go routines are really lightweight. You can run hundreds and thousands of Go routines easily, and um, to write a Go routine, you just have to write you just say Go and then the function name, and that's it. Um, so inside the code, if you run your function with the word Go um, at the front, it will run the processes concurrently. And when you run concurrent processes, one thing you have to keep in mind is, okay, what about the race conditions? And what about starvation? So Go has its own inbuilt synchronized package, which is sync, and it gives you stuff like mutexes and wait groups for you to use. So when you use a mutex, you can lock your Go routines from entering a critical section, and then have other Go routines to wait. And then wait groups gives you the ability to run Go routines, several Go routines, and then wait for the result of each Go routines by defining all of them in a wait group. And each Go routine would add themselves in the wait group and then say, I'm done to the wait group. And then um, the main function which waits for them uh, would know that if these functions are done. So if you want to run uh, a few Go processors to fetch, let's say you do API calls, 10 API calls, and then, and uh, let's say you can do this concurrently and they're independent. You can run the 10 API calls in Go routines and then wait for them and then combine their results, which would, if you have um, if you have multiple processors, physical processors that can run programs, then it will enhance your program's performance very well. The other thing about concurrency is that Go has something called Go channels. Um, Go channels is something when you run two Go threads, and then how these threads or routines can talk to each other. Um, it's by a shared memory space called a channel. So a channel can be a buffered channel or an unbuffered channel. So in a buffered channel, you can define the size of your channel. A channel is sort of like a queue where one Go routine would put um, elements inside this queue, and then another Go routine would write, read this from the queue. And in an unbuffered channel, which means the channel has no size, the queue has no size, it has just it can just contain one element. So when one Go routine writes inside this queue or channel, another Go routine would read this, and you can write a for loop, and let one Go routine just wait forever in that buffer until another Go routine writes stuff into that buffer. So two Go routines would share this channel where one writes, and the reader will wait forever in a for loop and just read whatever another Go routine would write into that. Um, so in a buffer channel, obviously you have a size. Then you can define, let's say, the channel can contain 10 elements at once, and then um, the reader uh, can read out 10 elements. And because in an unbuffered channel, when you write something into the channel, and if the reader has not read it yet, you can't write another thing. So if you've written something in an unbuffered channel and you try to write it again, there would be a deadlock if the reader has not read it yet. So you can avoid this by defining a buffered channel where you can write multiple stuff, um, and then have the reader read them out. Right. So in the previous slides, I've talked about that. Sorry about that. Okay. So in the previous slides, I've talked about that Go does not have classes. It does not have a class hierarchy. It has structs. And the relationship in Go is something different. If you are coming from an object oriented background, you would find this pretty hard to grasp, but it's actually simple. Um, it's just that you don't find the parent child hierarchy in Go. You have interfaces in Go where your structs can implement them and then use them in pub sub kind of design patterns. um, and you can use interfaces to let your client applications implement them uh, and then pass in their own arguments. But Go does not have the class hierarchy. So so when you talk about the class hierarchy, you would talk about inheritance, which means the child class would inherit everything from a parent. So Go handles this differently, which is from composition. And if you search in the internet about composition or inheritance, you would find many articles about how people should be moving to composition and just ditch inheritance. But it's not always the case, but you can achieve what you achieve from inheritance by composition, by doing a has a relationship over an is a relationship. So if I show you an example about this, so you find at the top, you see that there is a class, a parent class called a vehicle, which has an engine, and the vehicle class, um, so the car class is inherited from the vehicle. So car is a child of the vehicle parent class. So this is an is a relationship, which means the car is a vehicle which inherits the engine aspect of the vehicle. So one of the problems of this is that when your application grows, you would have multiple vehicles. Um, but let's say you have a vehicle that has no engine, right? So let's say you get a bicycle class right now, and then the bicycle class would also inherit the engine. And now you would face some trouble there because, okay, I can't do that. Then I would have to write something in the middle um, to separate those two. But it would take a fair bit of refactoring, um, because although this is a simple example, you would find more trouble in complicated systems. Um, in a has a relationship, which means a composition, you would you would see a vehicle, and you would also see a car, which is actually not inherited. Um this example just shows that a car acts like a vehicle, but the properties of the vehicle that inherits when it's a class hierarchy is now injected into the car struct itself with another struct. So which is a has a relationship. So you remove the engine aspect as a has a relationship, which could be another struct that has all the properties that um, a vehicle with an engine has, which is specific to the engine. And then you can have all your classes, all your structs, if it's Go, um, to have this engine struct included inside it. So it would get all the properties of an engine. So um, talking about dependency management, one cool thing in Go is that you don't need hosted dependency management services like npm or maven. um, you just need a repo, a Golang repo, which has the normal structure of a Go Lang project with the Go mod file um, uh, in the outside, and it's clearly defined. And if your project runs pretty good as a Go module, then you would have defined this in your GitHub repo, and then all you need to do is you just do go get and then the repo link, and these dependencies would be added to your Go mod file with just the GitHub repo. And then when you release stuff in GitLab or GitHub, you would have a release tag um, tagged in your commit, and then you can use that commit, the the tag version in that commit as the actual version of that dependent library. So it makes it pretty easy for people who use these dependent libs, and for people who release these dependent libs. Um, because let's say I have uh, a repository that I manage, all I need to do is just add a tag when I do a release, and then everyone would know when you go to the repo that there is a new version, and all they need to do is just update that tag version. And if they don't have the dependent library yet, they just need the GitHub link only, and you would have all the source code and stuff, and all would be managed inside your Go packages. So Go also has its own garbage collector, because I've told you guys before that Go has pointers. You can define variables in the heap, um, and you can also define variables as values. So when you pass pointers to functions in languages like C++, you would have to do the delete of that pointer by yourself. Otherwise, it would be a memory leak. Um, and languages like Java has its own garbage collector, because the Java code runs on top of the Java virtual machine. So Java has its own garbage collector. And although Go does not run on top of a virtual machine, it has a Go runtime, which the garbage collector runs alongside with your code, and it freezes your program for a small amount of time, and then it just goes through all the memory locations, which is not referenced anymore, and then cleans up your garbage, which is pretty efficient. And you also have, so in Go you also have the ability to define your variables as pointers and pass them as references, and then you also don't have to worry about um, managing the memory, because Go's garbage collector does that for you. So with all these features in Go, what I've seen Go used for is high performance scalable servers, and a lot of people are now moving from other languages which they have written because they want to write simple applications and they didn't want to write programs in heavy languages like Java. Um, and Go is now replacing them because Go's syntax and the coding style is pretty simple and it's pretty fast and it gives you all the um, functionality that you need to write really good microservices um, and also command line applications and mainly the HTTP server applications, which Go has its inbuilt support for HTTP, and Go also has support for uh, writing applications um, like when you have stuff that you need to let's say JSON, XML, and then protobufs, and Go has the ability to parse those for you in its inbuilt standard libraries. Um, so it's a good choice to write your web applications as well. And Go also has a large community writing good frameworks for Go. Namely, we have the Echo framework, the Jin framework that you can use to write good servers. And if you talk about um, what applications like popular applications that use Go right now, I can give you few small examples like Kubernetes, Docker, MongoDB, and a lot of Google internal um, data tools are written with Go uh, because of its simplicity and its fast performance. So I think that's about it. I've touched a small bit of stuff that Go offer, and when you write code on your own, um, you you would realize yourself that Go offers a lot more. It would take a bit of time for you to switch from an object-oriented conceptual languages like Java to Go, and that's the only thing. But if you're already familiar with C and C++ type of things, then it would be really easy for you to grasp Go because of its simplicity. Okay, so that's it. And if you have any questions, you can ask them right now from me.
Yeah, Ravi, we have some question.
Okay.
Situm Sandeep is asking, what is the best way to benchmark Go code?
Um, okay, so I can't actually give you a clear answer for that because it all depends on what you're trying to benchmark. Let's say you're trying to benchmark a test that would write something and then you read the response out from another end and then you can benchmark that. So it all depends on what you're trying to benchmark. If you're trying to benchmark to find the performance and the speed uh, which a small unit of code that runs, then you can do that. And I also use benchmark to do end-to-end tests as well. Um, so it can be used in several different ways. So it all depends on what you need to do.
And the next question is, does Golang have frameworks like Spring Boot in Java?
So Go does not need frameworks like Spring Boot because Go itself inside it has the HTTP server inbuilt, so you can use the Go standard libraries and do stuff that Spring Boot offers. I haven't used Java Spring Boot that much, so I'm not the best person to answer that. But if you're looking for simple and Laravel like syntaxes for your Golang servers, you can use frameworks like Echo and Jin, which are really popular. But they also leverage the stuff that Go offers, and you don't need to do. There is no Go Enterprise Edition or anything like. Everything is inside Go, so you don't need things like that.
So the next question is, what are some features from other languages that you wish were available in Go?
Hmm. Um, okay, so one thing I would like is um, a better way to manage errors, because um, whenever you get an error, you need to do the if error is not equal to nil, and then handle it manually, and it makes the code a little bit bulky, but it gives you an idea on what you exactly doing. Um, so a cleaner way to handle errors and um, yeah, a cleaner way to handle errors would be something I would like from other languages.
So, and the last question is, Kavish is asking, so is it possible to create Android app out of this?
Um, that's not possible because Go is a backend programming language.
Yeah.
Um, so for you to write Android apps, then you would have to use either native languages like Kotlin, or use frameworks like Flutter or React Native. But Go is a backend framework for your CLI and web apps.
I think that's all we got so far.
Cool. Thank you
So
very
let's,
much, guys, for listening.
yeah. So thanks for the informative session about Golang benefits, and I guess beginners got a better understanding about Go features. And uh, now I would like to thank you everyone who participated today's webinar. So until next time, see you guys.
Thank you. See you guys.